Hey, good morning. We're back. I gotta stop touching my face. I noticed I just watched my last video and realized how many times I touch my face. I do that quite a bit. I gotta stop doing that, especially in the coronacation we're on here. Another quick review I want to do is how to write a double displacement reaction and then how to balance it. So if you remember, we were doing that in chapter 7 before the world stopped. Just kind of want to remind you guys on how to do that, on how to put these two together. So if you remember, we're talking about double displacements reactions. They follow a general pattern. And that general pattern, if you remember, is going to be AB plus CD will yield AD and CB. All right, we got to get those together to be neutral and balanced, and we got to do the neutral first, and then we'll do the balance. Okay, so if I've got magnesium chloride and aluminum oxide, and I wanted to run this reaction and make two new compounds, you got to remember this is going to be where things split, right down the middle, right down the middle. So this is A, this is B, this is C, this is D. So we got to put them together in the right proportions over there. So the easiest part, we know we're going to have magnesium and oxygen over on the right. So I'm going to put those first. M, G, and O. I don't even know if that's neutral yet, but I know those are the two pairs that go together. And we're going to have aluminum and chlorine. So I'm going to throw those up here. Okay. Now that I've done that, I have to make sure that those compounds over here on the right-hand side, that those are actually neutral. So in order to do that, I need to use my periodic table, and I need to figure out what would be their charge when they became their ions. So if you guys remember, if you're in group 1, you make a +1 charge because you had one valence electron. You lose that electron, so you become +1 charge. If you are in group 2, you had 2 valence electrons, so you're willing to give those 2 up so you can get to the stable octet, so on and so forth. So everybody in group 2 was a +2. We said group 13 was a +3. Group 14 was that weird one, ±4. And then groups 15 were -3, group 16, -2, group 17, -1, and then the noble gases don't get a charge. So keeping that in mind, now we just got to look and see where our players are. So on the right-hand side, I've got magnesium and I've got oxygen. So magnesium, if I look at my periodic table, okay, and I've got mine right here, all right, magnesium is right here, okay? Right there in group 2. Oxygen is over here on the other side of the table, and it is in group 16. So you can see magnesium is in 2, oxygen is in 16. So that tells me a lot about their charges. So magnesium, when it made a charge, made a +2 charge, and oxygen made a -2 charge. You gotta ask yourself, does a +2 and a -2 give you 0? Yes, it does. Okay, so you're done. That one is just MgO and we're good to go. All right. Now I got to do the other 2. We have aluminum, which is right there. Okay, I'm going to use this hand. And then chlorine, which is right here. So we have a group 13 for aluminum, and we have a group 17 for chlorine. So from our rules from before, that means aluminum was the +3 charge, and chlorine is a -1. So +3, -1 doesn't give you 0. So I'm going to need more of the chlorine. I'm going to need a total of 3 of them. So this is where we can swap and drop when those numbers aren't the same. So I'm going to need 3 of those aluminums, or excuse me, 3 of the chlorines. Okay, get rid of those charges because neutral compounds don't have charges. So magnesium oxide and aluminum chloride. So we're good to go there. Let's clean this up a little bit. So we've written our neutral compounds, but now we don't have a balanced equation because if we look over here, I've got 2 chlorines on this side, and I've got 3 chlorines on this side. So when I'm balancing the equation, now all I want to use is I want to use my coefficients, all right? So I'm going to do this the slow, dirty way, all right? So remember, we did this before, kind of like a teeter-totter. I need the number of atoms on this side and the number of atoms on this side got to equal. So my players are, I've got magnesium, I've got chlorine, I've got aluminum, and I've got oxygen. It's going to put those in the same order over here. Magnesium, chlorine, aluminum, oxygen. Counting on the left, I've got 1 magnesium, I've got 2 chlorines, I've got 2 aluminums, and I've got 3 oxygens. Okay. Over here, I've got 1 magnesium, I've got 1 oxygen, I've got 1 aluminum, and I've got 3 chlorines. So at first case scenario, the only thing that looks good to me is what, magnesium? That's the only one. So we don't have to worry about fixing magnesium. Remember I told you to save oxygen for last? It won't matter here too much. This one isn't too scary, but we still want to just leave that one for last. So we'll just do the first one that comes wrong. So chlorine is a 2, chlorine is a 3. So the lowest number that 2 and 3 both go into evenly is 6, right? Okay, so what do I have to multiply 2 by to get to 6? 3. So I have to go out in front here. I guess I'll just use black. I was going to try something colorful, but I don't know if it's going to show up well. So coefficients only. So I'm going to go out in front of here, and I'm going to put something to adjust the number of chlorines. So we think 6. So I have to multiply 3 times 2 is going to give me 6 of those. That also changed my number of magnesiums, right? So that became a 3. We'll worry about that in a second. Let's fix the chlorine over here. Chlorine over here is over. I need to put a 2 here because 2 times 3 gives me 6. That also gave me 2 aluminums. Okay. So looking at my damage, I've got my magnesiums are still not good. My chlorines are good. My aluminums are good. The oxygens are off. In fact, 3 and 3 on this side, 1 and 1 over there. So if I put a 3 in front of that right there, that's going to give me 3 magnesiums, and this is also going to give me then 3 oxygens. So then if I look, 3 and 3, 6, 6, 2, 2, 3, 3. So a 3, didn't have to put anything there, a 3, and a 2. So we were able to write neutral compounds, and then we are able to balance the chemical equation, right? So just a quick refresher on how to do those things. We'll do more again soon.